Okay, so this is lesson 3 on the cosine rule. Today we're going to be looking at how to solve problems, worded and contextual problems using the cosine rule. Okay, so up to now, just to summarize what we've done, you've looked at basic trigonometry, SOHCAHTOA. You've looked at the sine rule last week. This week we've been looking at the cosine rule, so sides and angles, and then today we're looking at applying the cosine rule in different situations, usually when it's mixed with different topics or it doesn't necessarily draw you a triangle, so you have to draw your own triangle or it's a worded problem, that kind of thing. So the key thing with problem solving, guys, is that we need to read the questions carefully. Usually that means more than once, read it again, read it a third time, and then get in the habit of sketching a diagram. This is a really important step because often these questions don't give you a diagram. So the harder style trigonometry questions don't draw something for you. Well, they might talk about ships traveling on a bearing, or they might talk about ladders leaning against walls, or they talk about kites flying in the sky, all sorts of different types of question, but they don't give you a diagram, so you have to draw your own. Okay, so that's the second step. Third step, being clear on the details you've got. So in that question that they talk about, planes flying in the sky, they will tell you how high the plane is, or they'll tell you what bearing it's flying on, or they'll tell you the angle of elevation or depression. So you have some details which you can add to your diagram. The fourth thing really is being clear on what the question's asking you for. So are they asking you to work out an angle? Are they asking you to work out a side? Is it a distance? Or is it something different entirely? Is it a bearings question? Or is it a speed, distance, time question? That sometimes does get mixed with trigonometry. Okay? Above all, as was the same with problem solving when you're using trig, a basic trig I'm talking about, spot the triangles. So whenever you draw these diagrams, you draw the plane flying in the sky, you'll be able to see a triangle, and sometimes it will be a right angled triangle, sometimes it won't be, but now we've done the sine rule and the cosine rule, whether it's right angled or not, you can still use a method. Okay, so try and spot the triangles. Let's take a look at an example. So take a second now and read this question. Ship A leaves port P and travels on a bearing. Bearings is a topic here that is linked to this, of 200 degrees. A second ship, ship B, leaves the same place, same port, and travels on a different bearing, 165. After half an hour, ship A has travelled 5.2 kilometers and ship B has travelled 5.8 kilometers. How far apart are these ships after an hour? Right, I'm going to do this using the visualizer. So what I would do if I were you is, for now, have a blank piece of paper and get ready to copy the diagram I'm about to draw for you. Ship A leaves port P on a bearing of 200. Before we go further, I want to talk to you about what bearings are. So let's think about bearings for a minute. Bearings. I'm going to have to cut that out. Okay, so before we get into the question properly, I want to talk to you about bearings. Bearings, in case you don't know or haven't covered this yet, are basically a way of telling you what direction something's travelled in. So, for example, if I say I'm stood here, and I'll just put an A, and I turn to a bearing of 80 degrees, what that means is you measure always from north. Okay, bearings are always measured from the north line, and if I said 80 degrees or 080, that means you turn 80 degrees that way, which would be something like that. That would be 80 degrees or 080. As a bearing, it's got to be 3 digits. Okay? So, turn to a bearing of 80 degrees. Now, applying what this question says, it says a ship leaves port P, so I'm just going to start port P in the middle of my diagram here, and it travels on a bearing of 200 degrees. So from the north line, there's north, 200 degrees, well, this would be 90, down here would be 180, so 200 is somewhere in this direction, so I'm going to draw a line over here. Okay, and I'm just going to draw an angle there and say 200. That's 200 degrees. And that's where this ship A has travelled. I'm just going to write an A here. That's where A has ended up. Okay. A second ship, ship B, leaves the same port and travels on a bearing of 165. So again, 90, 180, 165 is probably going to be something like that. So 200 is the bigger one. This one here is 165. Okay, and that's ship B. Next part of the question says, after half an hour, ship A has travelled 5.2. So I'm going to write 5.2 kilometers there. And ship B has travelled 5.8. So I'm going to write 5.8 kilometers there. What's the question asking us to work out? How far apart are the ships? So they want us to work out this distance here. Okay? Now what comes next is deciding which of the formula to use, and the way we do that is first to add one other bit of detail to this question, which is the angle that goes here. Now the angle here is 200, but take off this bit. If I just shade that bit in. Now the bit that's shaded is 165. So 200 take away 165 is 35 degrees. So I've just worked out that I have a triangle, I have two sides, and I have 35 degrees in the middle. So I'm going to actually redraw this diagram, but I'm going to simplify it. Okay? So here's how I'm going to redraw it. I'm going to get rid of the bearing part, don't care about that, don't care about that. And don't really care too much about the question now because I can just look at my nice triangle. I've got P, which was the port, and I've got the two distances and the angle between. So, question 1, is it a right angle triangle? No. Question 2, do I have a matching pair? No. Question 3, do I have an angle sandwich? Yes, we do. I have an angle sandwich. I'm finding the opposite side. So, at this stage, I will recognize that I'm using the cosine rule and I'm working out a side. So, the formula that we should know is a squared equals b squared plus c squared minus 2bc cos a. And remember what I told you, it doesn't actually matter what the letters are. What you're thinking about is the two sides you know and the angle between. So, x squared, I'll write x squared, the one that I'm working out is, let's call this one b, let's call this one c, and this, which I know is called p, that's my angle a. So 5.2 squared plus 5.8 squared minus 2 times 5.2 times 5.8, I'm running out of space here, times cos 35. Now you need to put that in your calculator. And that gives me an answer of x squared equals 11.26874869, and obviously square root both sides, so square root that answer, and my final answer then is 3.356895692. Finally, I'm going to round this to 3 significant figures, and that gives me 3.36 kilometers. So I've just worked out that the distance between these two is 3.36. Okay? So we started with a worded problem. I'll just remind you, we started with this. And from that, I drew myself a diagram. I identified what rule I'm using because I had an angle sandwich. And then I answered the question. As a minimum, I'm expecting you to do the red activity. That is the easiest question. Now, this is very, very similar to the one we just did as an example. So you have two bearings. Using those two bearings, you can work out one of the angles. and you can draw yourself a diagram. So the first thing I would do for this red question is to draw a diagram and label the bits that you know. So you've been given two distances, you can work out an angle, you should therefore have an angle sandwich, and because you have an angle sandwich, you should know that you can use the cosine rule. For the amber question, what you can do is, again, you can see an angle sandwich there, so you can work out a length AC, and the way you do that is using this side, and the angle between. Once you have length AC, you can work out CD, as the question part B says, work out CD, because once you've got AC, you've got another angle sandwich. And the green question, this is really for set 1 students and for those at the top of set 2. It's a question involving regular shapes. Now, because the shapes are regular, you know that all lengths are the same. And if you know that the perimeter of the octagon is 40 centimeters, you can work out what one of the lengths are, because an octagon has 8 sides, so 40 divided by 8. And then using that information, you can work out the bits that you need. The other thing is, because they're regular shapes, you can work out the interior angle. I'll remind you, we did this topic in school actually before the lockdown. This is about interior and exterior angles of regular polygons. Okay. Good luck with those. Take a picture of your answers and submit onto MathsWatch as usual to complete your homework. Thank you.